Okay, so we're going to look at factored form of a quadratic equation and how we can use factored form to determine the zeros. So there's your factored form, ax minus s, x minus t. And so we know that factored form gives us the zeros, and I had mentioned that s and t are the zeros, but I think it's really important to understand how we come across the zeros. So the methods that I'm showing you in this video are most important because, sometimes teachers will say, okay, well, just take s and t and take the opposite sign. So, if it's negative here, then you take the positive of that number. And if it's positive, you take the negative. But that's not based on understanding. And I think it's really important to understand how we go about finding these zeros and why s and t in this particular equation are the zeros. So the first thing we need to recognize is, why are they called zeros? They're called zeros for a reason. So I've got a graph over here, and I'm going to label the coordinates of the x-intercepts, or the zeros. So I've got one here. This is at 3, 0. And I've got another one here at -2 and 0. And when I think about it, what is in common to both of these points, and what's in common with any points on the x-axis? Well, the y value is equal to 0. So they're called zeros because the y value is equal to 0. So when I say zeros, that's a keyword for you to set the y value equal to 0. So that's the first thing we're going to do, is set the equation equal to 0. Okay, so now I'm multiplying things and I need to get an answer of 0. So what do I know about multiplication and getting an answer of 0? I know that when I multiply anything by 0, I'm always going to get an answer of 0. So I'm going to identify here, there's an a, I'm multiplying that times another multiplication here, and I've got a third multiplication right here. So I'm multiplying 3 things. The first thing I need to understand is a is just a number. It's not a variable. So when I give you an equation, that number is filled in for it. It might be 1, it might be -3, it might be a half. So that's just a number. So that's going to have no bearing on whether this turns into 0 or not. It's wherever there is a variable that matters to us. So this factor here has the x in it, and the x can take on different values. So I need to figure out what values of x are going to make this thing equal to 0. Because I know that if this guy is equal to 0, it doesn't matter what this is, it doesn't matter what that is, the whole side is going to be equal to 0. So I'm going to solve where x minus s is equal to 0. And if I move this to the other side by adding s, then we get x equals s. So there is one of our x-intercepts, x1 equals s. That implies that s comma 0 is one of the x-intercepts. Likewise, if this thing is equal to 0, so if x minus t is equal to 0, then it doesn't matter what x minus s is, it doesn't matter what this is, the whole thing's going to be 0. So if I bring this over to the other side by adding t, I get x2 equals t. So there are my two x-intercepts, s0 and t0. Okay, we could also just say x equals, s comma t. You don't want to put a bracket because that implies it's a coordinate. It's not. So you could state them like that. You can state them like this, or you can state them like coordinates. So this right here is the method of how to find the x-intercepts. Okay, so we're going to do a bunch of examples. Here we go. This is in factored form. I'm going to find the zeros. So the first thing is to set the y value equal to 0. And then I'm going to identify the things that are being multiplied. So I have this guy right here being multiplied by this guy right here. So I know that if x plus 3 is equal to 0, then I'm going to get a product of 0. So bringing that to the other side, x equals -3. There's one of my x-intercepts. And then I know that if x minus 5 is equal to 0, bring that over. So there are my two x-intercepts. So -3, 0 and 5, 0 are the solutions to that. Another one here. So find the zeros, keyword 0, set y equal to 0. Then I'm going to identify the multiplication. So that thing is being multiplied by this. If you have difficulty identifying what's being multiplied, if you read it out loud, oftentimes that tells you where the multiplication is happening. So if I was to read this out loud, I would say 3x times x minus 4. So that tells me that 3x is being multiplied by x minus 4. So I'm going to find where 3x is equal to 0, dividing both sides by 3. 0 divided by 3 is 0, so there's one x-intercept. And then x minus 4 is equal to 0 at 4, and x equals 4 is the other x-intercept. Okay, here's an example where I don't like just picking s and t from the equation. So if you said -1 was an x-intercept, you would be incorrect. And that's why I think the methods are really important. So setting that equal to 0 and identifying the things that are being multiplied, and then solving for where those things are equal to 0. So step 1, I'm going to move this to the other side, giving me -1, and dividing both sides by 2, x equals -1/2. You must leave all fractions in reduced form. Do not convert to decimals. The only time I would say is convert to decimals for yourself when you are going to graph. So for example, I know that's -0.5. It makes it much easier for me to graph the decimal as opposed to thinking about it as a fraction. But on paper, when you're giving your solutions, you have to leave them in fraction form. And the other one here, x minus 5 is equal to 0. Okay, so there are my two x-intercepts. Another example here, find the zeros. Okay, I am multiplying this has an instance of x and this has an instance of x. So 2x minus 3 equals 0, moving the 3 over. 2x equals +3. Divide both sides by 2, so x equals 3 over 2, which for me is 1.5. That's when I'm graphing, so there's one x-intercept. And then the other is from 3x minus 4. 3x is equal to 4. Divide both sides by 3. X equals 4/3, my other x-intercept. And for me, this is 1 and 1/3. So when I graph that, it's much easier to plot. Another example here, I don't see two brackets here, but this is factored form, and it's also vertex form because it does follow vertex form where a is equal to 1, so there's a 1 here, and plus 0, so the k is a 0, and there's the x value of my vertex. But it is also factored form because I could write it like this. X minus 8 squared is 2 binomials. So that is factored form. And because I have two brackets that are the same, essentially when I go to solve for the x-intercepts, I really only need one of them because they're the same. I'm finding where x minus 8 is equal to 0, which means it has an x-intercept at 8. So what does that look like when I'm graphing? Let's see if I can move this. Okay, so let's just 2, 4, 6, 8. I'm not using the actual graph. So that means I have an x-intercept here, but if I'm only having one x-intercept, and the other thing I note that it opens up, so the parabola is going to open up, like this. I need another point to graph, so actually let's practice that here. If a is equal to 1, then it has the same step pattern as y equals x squared, so I can easily plot that. This is 6 and this is 10, so this means I go over 1, up 1 from the vertex, and so this would have to be the vertex, so over 1 and up 1, over 1 and up 1. That's the only way to have a parabola that hits the x-axis once, is if the 0 is also the vertex. Okay, so that coordinate here, when you have one root or 1, 0, that point has to be the x-intercept, the vertex as well. So that's your method for finding the zeros from factored form. That process is really important. So setting the y value equal to 0, identifying your multiplications and setting each of those factors equal to 0 and solving.